Isaac Newton, born in 1642, was a curious child from the start. His inquisitive nature set him apart from other children his age. Growing up on a farm in England, he was fascinated by the world around him. The rolling hills and the serene countryside provided a perfect backdrop for his explorations. He built sundials, water clocks, and even a working model of a windmill. These early inventions were a testament to his budding genius and relentless curiosity. Despite his intelligence, Newton faced challenges. The path to greatness was not without its obstacles. His father died before he was born, and his mother remarried. This led to a tumultuous childhood, filled with emotional and familial complexities. He was raised by his grandmother and later sent to boarding school. The separation from his mother was difficult, but it was here that his academic talents began to flourish. School was tough, but Newton's brilliance shone through. His teachers quickly recognized his exceptional abilities. He excelled in his studies, showing a particular aptitude for mathematics. His love for numbers and problem-solving became evident early on. At 18, Newton went to Cambridge University. This was a pivotal moment in his life, marking the beginning of his formal education in higher learning. It was a time of great intellectual ferment. Scholars and thinkers were constantly debating and discussing new ideas. Ideas about the natural world were being challenged and redefined. The scientific revolution was in full swing, and Newton was right in the middle of it. Newton thrived in this environment, absorbing knowledge from his professors and diving deep into his own studies. He was like a sponge, soaking up every bit of information he could. Little did he know, he was about to embark on a journey that would change the course of science forever. His contributions would lay the foundation for many scientific advancements to come. At Cambridge, Newton's genius blossomed, setting the stage for a series of revolutionary discoveries that would change the world forever. He made groundbreaking discoveries in multiple fields, from mathematics to physics, and even in the study of light and optics. One of his most significant achievements was developing calculus, a new branch of mathematics that provided a framework for understanding complex changes. Calculus provided powerful tools for understanding motion, change, and other fundamental concepts in physics. Newton didn't stop there. He continued to explore and innovate. He revolutionized our understanding of light and optics, conducting experiments that would lay the groundwork for future scientific advancements. Through his meticulous experiments, he showed that white light is actually a mixture of different colors, a discovery that was groundbreaking at the time. This discovery led to the development of better telescopes and a deeper understanding of how we perceive the world around us, enhancing our ability to explore the universe. Perhaps his most famous contribution was his 3 laws of motion, which provided a comprehensive framework for understanding the physical world. These laws explained how objects move and interact with each other, from the smallest particles to the largest planets, offering insights that were previously unimaginable. Newton's laws of motion formed the bedrock of classical mechanics and laid the foundation for our understanding of the physical world, influencing countless scientific advancements and shaping the future of physics. The story of Isaac Newton and the apple is legendary, often told in classrooms worldwide. As the story goes, Newton saw an apple fall from a tree in his garden, sparking a monumental breakthrough. This simple event led him to wonder, what force pulled the apple to the ground? Newton began to ponder this force. He realized the same force must keep the moon in orbit around the Earth. This was revolutionary. Newton named this force gravity and dedicated himself to studying it. Through rigorous calculations, he formulated the law of universal gravitation, a testable and verifiable explanation. Newton's law stated that every object attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. This idea revolutionized our understanding of the universe, explaining planetary orbits and tides, and laid the foundation for modern physics and astronomy. While Newton is best known for his scientific achievements, he was a man of diverse interests. He was deeply religious and spent years studying theology and biblical texts. He was also fascinated by alchemy, the ancient practice of trying to transform base metals into gold. Newton served as a member of Parliament and later as Master of the Royal Mint. In this role, he oversaw the production of British currency and worked to prevent counterfeiting. He was also president of the Royal Society, one of the world's oldest and most prestigious scientific organizations. Newton's interests extended far beyond the traditional boundaries of science. He was a true polymath, a testament to the boundless capacity of the human mind. He left behind a vast collection of writings, including scientific treatises, philosophical reflections, and theological musings.